over the top of it, if you're an athletic trainer, is you just overwrap it, stops the athlete playing with it, because if they're used to taping, they'll want to be able to feel this.
Yeah, true.
Right? Or if they're used to,
they want to tighten it down, or
whereas
okay.
it works by eliminating the causes of acute ankle pain, which are the ligament stretch as your foot comes off the ground. The lateral ligaments stretch through the inertia and weight of the foot. And then also when your foot hits the ground, you're unevenly loading the medial talus, right? And that's where you get what I call point loading pain. I've had to invent a few terms to explain why it can mobilize an acute sprain. And so that's where the biomechanics of ankle pain, ligament stretch pain, and point loading pain are what's going on. So if you simply, and they could do it with tape for a while, if you simply provide force, mild tension up the inside, you've got the mild tension there and tension on the outside, that'll pull your joint together and you can start walking again. Right? So, and that's where, and you don't need physiotherapy normally then, because your ankle's being held together, the ligaments are back in their shortened position, and they're being exercised. And that's what I was saying about limiting your subtalar joint range of motion. It goes side to side, and above it is the up and down motion of the tibiotalar joint, and that's a combined universal joint.
Right.
It's where restricting that subtalar joint just means that rotation has to occur now at the tibiotalar joint, which is going to compromise the lateral ligaments you're trying to protect. And that's what I was saying about any brace that restricts the subtalar joint shouldn't be worn on lax or injured ligaments, because it's going to transfer when you try and roll your ankle out. This can't happen. You can't resolve rotation through the combination. It's going to happen at the tibiotalar joint. Instead of going up and down, it now starts to do this. And on the medial talar dome, where the osteochondral lesions and your post-traumatic ankle osteoarthritis develop. So simply by holding the joint together with mild tension up the inside and outside, that is what eliminates the pain and the acute sprain. So that's where, I have no trouble selling that concept to ankle surgeons, because it was ankle surgeons that told me that's what they wanted. They wanted to be able to hold the ankle mortise together for extended periods of time. But I find a lot of resistance. You might have found it too when you spoke to physical therapists, that allowing that subtalar joint range of motion is just something they haven't done before. They say we support the joint by putting these straps up the side of it and, restricting the subtalar joint. They're not actually supporting the tibiotalar joint, which is what you've got to support, right? If you put that back together, the stability is created by the interlocking of the surfaces, like a bit like Lego. If you take the two pieces of Lego apart a little bit and twist them, you can pull them apart. But if you lock them down together, they lock in. And that, what we found with Sydney University study versus the Aircast on chronic ankle instability, was that after people with or without chronic ankle instability felt more stable doing their side hops and other exercises with this brace on, versus the Aircast, which has the rigid straps, the rigid stays up each side. And that's what I've been saying, is that the stability isn't actually created by necessarily a rigid force. And all these braces that say we support the ankle joint, or taping to support the ankle, aren't actually supporting the joint that you actually want it to go. So getting over all this misconception and miswording of things is one of my biggest challenges. The perception of a brace that has to actually stop you going somewhere, whereas this just supports and uses time and range of motion as a preventative effect. Like you have now As soon as I realized that the inversion is safe, that's when I realized, okay, well, that means that this entire range of motion here, right, is a safe zone. All I need to do is use these ligaments, the elastic in here, and this to stop the rigid, the end point. And I have all this time as it extends out, and the body's externally rotating as well. It's all part of what I call impulse suppression. It's the same as the helmets. And if I'd done an interview with you and talked to you 6 years ago, I would have told you that the helmets should be the other way around. They're completely inside out. If you put the soft part on the outside and the harder shell just around the head, right, like an afro, then you'll prevent more injuries, because you're just going to then go woo, and your head's going to go woo, and stop the controcute. The controcute is the one that causes bang, and the brain sloshing around. You don't want to stop the head. You want it to keep going. So that's why I just saw something recently where they're now the NFL saying you can wear the over helmet
Guardian
thing.
caps. Yeah,
Yeah.
we've starting to see more compliant football helmet shells, American football helmet shells. And that's the idea, yeah. You get some decoupling to happen on the exterior of the helmet before it decouples to the interior part of the padding, obviously before it gets to your skull. And so yeah, durability is always a question mark with some of these outer exterior mounted devices, shell add-ons, but you know, more padding is generally better anyways. But yeah, more compliant shells is kind of the current trend. So we'll see where they go.
Yeah. So if I had well, I've got enough on my plate already, but I'd be making it just out of a soft, dense foam with an inner shell that's against the skin, but might have a foam and lining it as well. But it's basically just a foam, so you can press it in. You know, when you're hitting it, it's going to, so it's spreading the force over time. So that's what the ankle brace does, right? So that's where, and that's what makes it possible to drop a bowling ball off it. You saw that video I sent through. I've just done some tests. This is a new one here we've just tested. All right, I just attached the bowling ball. This is a rigid strap. Well, as rigid as you can get a nylon straps. The sort of straps you use for locking down cargo and things.
Yep.
And then the bowling ball, I'll just attach it to. So that's an 11-pound bowling ball. So I've calculated, I haven't done as slow, high speed videos yet, but I'm setting up to do it. But it's traveling at about 10 miles an hour when it goes through a meter. And that tests basically the shock force holding of these anchors, right? The anchor underneath here, right? Because if you look at the direction of the doing it, it's kind of safe to do it, because it's not going to actually twist your ankle too far because of the direction it's going in. But what it does is show you that you can store up that much energy and resist that much shock force in those anchors. Whereas this Biodex test, we did it a pilot with Sydney Uni as well. Do you know familiar with the Biodex?
Biodex?
Yeah, it's the machine that runs you through a range of motion, and it measures the force of resistance. So we were able to put this various ranges of motion, but this is as fast as this machine would go. You're seeing that, yes?
Yep.
43 degrees plane of flexion at 250 degrees per second. So it's locking up, and at the end we have a plot of this. And to me, So that's that, and then now here we have the plot. No. Right. So what this showed was that so what we did was put somebody into the brace, into the machine, measured their normal range of motion, how it felt safe up to there, put the brace
Yeah.
on them, back in the machine, measured before and after. So as it's starting to kick in, from the plots, we realized that there's 150 newtons of extra force just as it started to kick in, and now it's just starting to climb. Okay, as the range of motion continues, the further it goes, it'll just continue to go up. I don't know where that goes because I can't really do it on a human being. And that's where the crash test ankle comes into play, right? One that you can, so for me, this area under the graph here, I know, and in between here, we'll start here, in between, there's around, what's that, 5 kilos of force in between here, so which is what's holding the joint together the whole way through, right, through your whole range of motion. So that's what stops the pain of an acute sprain. But the total area under this graph, if you could continue it on over time, right, if you did it over time rather than range of motion, should be an amount of energy. And if you can equate that amount of energy that these braces can store up is greater than the amount of energy it takes to sprain a ligament, then it should be safe.